thank you for coming to not the Bootstrap, but the ultimate Bootstrap for MySQL on Windows. I'm George Trujillo, and I will be presenting to you. When I was looking at putting this together, I was thinking of taking you through the steps of how do you install MySQL on Windows, but that's not where people are having problems. I can get my 9-year-old kid to install MySQL on Windows. The reason being is, you download the MSI installer, just keep hitting next, the installation will not fail. But the problem is how people set it up, how they implement it, how they want to use it. That's where people make all the mistakes in terms of setting up with MySQL. So my goal is not only to teach you a little bit about MySQL, but to make sure, more importantly, that you're directionally correct. If you're an Oracle DBA or you're a developer and you're very technical, you can learn the commands. That's, as I said, not where people have problems. So let's go ahead and get started. The first thing is, it's MySQL. It's not MySQL. I came from MySQL before it was purchased, and when we were fighting the Antichrist, all 400 of us, we called it MySQL religiously because, as you know, SQL Server gets abbreviated as SQL. So to say SQL is like calling the boogeyman, right? Sooner or later the Antichrist is going to come. So it's MySQL. What we're going to be talking about is the MySQL architecture. Before we get started, how many of you are currently Oracle DBAs? Okay, excellent. So what I'm going to target this presentation a little bit more for is for people that come from an Oracle background to say, here's how you do this in MySQL, and here's how it compares to Oracle. So as you all know, to work with any database server, you've got to understand the architecture, so we're going to give you a good fundamental understanding of the MySQL architecture. Second, I'm going to do a comparison analysis between MySQL and Oracle. We're going to take a look at best practices, how do you install it right? And this is one of the biggest issues I have with customers that are working with MySQL, because if you go out and spend $1 million or $10 million for an Oracle license, you're going to make sure you get somebody very experienced and very good to go out and set it up. So what happens? People download MySQL and they use it for free, so then they think anybody can install it, anybody can set it up. It's still a database server. If you don't install it and configure it and tune it properly, it's not going to run right. So you'd better put as much effort into setting up and configuring your MySQL database as you do your Oracle database server or any other database environment that you're working with. We're then going to take a look at what are the top 10 things to make sure that you do correctly once you install the MySQL database server. We're going to take a look at the MySQL value proposition and make sure that you take a look at what MySQL is. If you're going to ride a motorcycle, if you're going to ride a semi-truck, if you're going to be in a Rolls Royce, they're all going to allow you to drive down the highway, but the way you use that is going to be completely different. When you're working with the MySQL database server, you need to understand what it does really well and things it doesn't do as well to make sure that you're optimizing working with this product. And then we're going to take a look at why MySQL is so strong on Windows. First of all, in terms of working with the database server, you all know that you have a configuration file. So coming from the Oracle environment, you've got your init.ora file, your sp.ora file. If you're working with SQL+, you also have your login.sql file. MySQL has something very similar. We have a my.ini file or a my.cfg file. The my.ini file is the standard file on Windows. The CFG is the one that comes with Linux or Unix. And the way it works is, once you install MySQL, it has a default search path where it's going to go look for the software. And in any directory it looks in for the software, it's going to check to see if there is a my.ini file on Windows, and if it doesn't find it, it'll then look for the CFG file second. If you're on a Linux or Unix-based system, as it goes down the search path, it'll look first of all for a CFG file in that directory, and if it doesn't find it, it will then look for the my.ini file. The my.ini file is an ASCII text file, and what's a little bit different about it is when you're working with Oracle, you'll have your init.ora file or your configuration file for the database server, and then you'll have like a separate configuration file for SQL+ and for any other products that you're working with. What MySQL does is they put the configuration file for all those environments together into a single file, what you see up here. So first of all, the back-end server that we're going to talk about in a little bit is the MySQL D background process. So below the MySQL D section, you see here in square brackets, that's where you have all of your server parameters, how you set up your caching, how you set up your paths, the maximum number of connections. But you also have a client tool called MySQL. MySQL, the client tool, is the equivalent of SQL+. You know how you can go out and set up a configuration file for SQL Plus to customize your environment? Well, you can do the same thing for MySQL. It's just that you'll have this MySQL section here in square brackets, and below that section, you will have all your parameters that you're defining for the MySQL client. MySQL has a number of additional client applications. For example, one is SQL dump or MySQL SQL dump that allows you to do logical backups. So if I want to set up my environment for logical backups and I don't want to put all these parameters on the command line, when I do a backup, I can get all those parameters that I'm using over and over again, and I can put them in this category here below MySQL dump. So that way when I execute the backup tool, it's going to go look at this configuration file and run it. So probably the first common mistake that people make when they first start making with MySQL, if you get a server parameter and you do not put it below MySQL D, you instead put it below the MySQL client section, it's not going to boot up your server. It's going to say, you know what? Or when you try to bring up that software, it's going to go out and say, you know what? This configuration parameter isn't right. Looking at this here, we see that there's two important directories that you have when you first go out and set up MySQL. The first is your baster. That baster parameter is going to go out and specify where your software is. And you can call it Mickey Mouse, Donald Duck, Pluto, whatever you like. Here it's called OPT MySQL 5.1.50. You also have a data directory, and you're going to see that different than Oracle, the MySQL database server is very tied to the operating system directory structure. So where you define your data directory, that's where MySQL is going to have all your persistent storage for all your database schemas and your tables. And then in Oracle, you know how you have your alert log? MySQL has something very similar, but we call it the error log. So you can go out and specify the path and the location and the name of that file. You also have a process ID file. When the MySQL background process comes up, it will put the unique identifier for that background process in your PID file. When it shuts your server down, it'll get rid of the PID file. You also have a number of log files you can work with that I'll talk about a little bit later, and you can also specify the path for them. When you connect to an Oracle server, you specify the Oracle SID, or you specify the service that you want to connect to. In MySQL, you specify the host name, or the IP address where the MySQL database server runs, and you specify the port number. So if I'm going to have multiple MySQL database servers running on the same machine, then each MySQL instance must be on its own port. So when we go to connect, we have to specify the port that we want to connect on. You see here in the configuration file below the MySQL D section, when this server comes up, it will be looking for requests that are coming through port 3306. Now, this port is the default port for MySQL. Below the MySQL section at the very top, that's for the client tool. If you don't specify the port, the default port is 3306. But if on the client side, I want it by default to connect to a different database server, I can have the port parameter again, and I can say port equals 3307. So when that client tool goes to connect, it's going to go out and look for a different database server. The big thing that everybody talks about, but I'm not sure they completely understand, is storage engines. You've been working with storage engines all along, you just haven't realized it. When you work with an Oracle database server, you work with server processes. They get your SQL command, and they will go through, and your server process will parse your SQL command, build an execution plan. Then it will execute database code that goes out and enforces referential integrity, makes sure that you have a valid primary key, etc. So the thread does the first process, or the server process takes care of the SQL command, but then the database server takes a look at the execution of that code in the database server. MySQL works the same way, but it uses a slightly different approach. The way Oracle tables and indexes work, anybody that's looked up the create table command in Oracle, you go create table and there's 5 billion different features, right? The way MySQL works, it's like you going out and buying a car. I might want to go out and buy a Corvette. Well, if you buy a Corvette, what characteristics are you looking for in a car? I want something that's very fast. I want something that can hug the road. I want something that can accelerate really well. But that Corvette is probably not going to do too well up in the mountains when it's icy in Colorado in the middle of January. Or you get an SUV. It's going to be a lot more durable, it's going to be more rugged, it's going to do better in the snow, but it's not going to do as fast on those mountain curves when it's July 4th and that Corvette whizzes by you. So you pick the right car to leverage the characteristics that you're looking for. That's how in MySQL you work with storage engines. So you go out and you create a table, and you define your primary keys, your foreign keys, whatever you want, all your columns, just like you would with Oracle or any other database server. And at the end, you specify engine equals. And then that's like you're associating that table with the Corvette storage engine, or you're associating it with the SUV storage engine. So whatever storage engine you associate that table with, it'll take on those characteristics. First of all, you have MyISAM. And this brings us into what is the flavor of MySQL. When MySQL was first created, it was designed to be a web reporting database server. It was designed to be very, very fast for web applications. It's one of the first core databases that was actually built after the internet was created. So when you look at Oracle and SQL Server and DB2, etc., they were all created to be OLTP databases from 30 years ago. So what MySQL did is if you're building a web application, I go into companies where if data doesn't come back in 3 seconds from a web company, that's considered a data outage. So it has to be very, very, very fast. So the purpose of the MyISAM storage engine is to be very fast for reads. So how did they make reads very fast? They took all the protection off. Because if you're going to be focused on reading, you don't need to worry about enforcing foreign keys, correct? So anytime you need to do very fast reads and you need to do bulk inserts very fast, the MyISAM storage engine is going to rock. Now, coming from the Oracle world, you guys are thinking about OLTP, data integrity. If you want a transaction storage engine to enforce foreign keys and so on, you want to work with the NODB storage engine. So here's a simple example of going out and creating a table. I go out and define the storage engine. Here I pick MyISAM. And what if I realize, oh, you know what? I need to build foreign keys. I need another type of storage engine. I should have made it NODB. It's very easy syntactically to go out and say alter table, whatever the name of my table is, and choose a different storage engine. So syntactically, this is trivial. But the only thing is, what if this table has 30 million records inside of it? What it will do is, it will go out and create that table, generate a block, it'll create new storage, move all the data over, and then eliminate the old storage. So how long is that going to take? So syntactically, it's pretty trivial, but I recommend you not do that at 2 o'clock on Monday, right before your yearly evaluation. What you can do is, the default storage engine, remember MySQL was initially designed to be a web reporting database. The default storage engine is MyISAM. Now, to make it very fast for reads, whenever anybody does an update or a delete, and depending upon the configuration of insert, it locks the entire table. So it's not going to support concurrent transactions. In fact, it has no before and after image. Whenever you do an insert into a MyISAM table, it makes that change physically on the disk. So there's no rollback capability. So just make sure that when you're working with MySQL, you're working with the right storage engine. I go into companies and go on, I've heard all these great things about MySQL, but it's really slow. Our transactions are atrocious. And then you find out they're trying to do concurrent transactions. Anybody that does an update locks the entire table. Everybody has to wait for it. So it's kind of like somebody going out and buying a Corvette, and in the middle of January in Colorado, they're stuck at a stop sign spinning, they can't move forward, and they're going, this Corvette isn't any good. No, you didn't get the right vehicle for the way you want to use it. So here, when you go out and go to install MySQL, you have to understand the installation process. Now, the installation process at MySQL is brilliant. It's also horrible. Now, you understand, how do big database companies make money? You go out and pay big licenses to use their software. MySQL, you can get it for free. And you can keep using it for free. So how does MySQL generate revenue? MySQL wants millions of people to use MySQL, and hopefully a small percentage of them will be willing to pay for it. And if that percentage increases a few percentage points, that can generate tons of revenue. 3 years ago, over 3 years ago when I joined MySQL, industry analysts said that there were over 12 million MySQL instances up and running. Now the estimates are anywhere from 80 million to 200 million instances being up and running. So MySQL is very, very popular for the internet. So how do we get somebody to want to choose MySQL? If they go to install it and they have problems installing it, they're probably going to pick something else, right? If they're getting something for free. So the goal of the MySQL installation is to say, we assume that you're not a database expert. That if you're installing on Windows, you probably know Windows. So what we're going to do is we're going to make that a good install for a Windows environment. So for example, all your software and data files are going to be below program files, that directory structure, or they're going to be below documents and settings for where a Windows administrator would be installing Microsoft Word or Excel. So for a simple Windows installation, for somebody that doesn't know databases, that's brilliant. It's also designed to be a very simple install in terms of taking minimal resources, so that database server that it creates is very under-configured to make sure that your installation does not fail. So obviously, if you try to use that configuration file that's very minimally configured, you're not going to be able to expect it to run very fast, right? Now, it depends on how you were raised by your kindergarten teacher. My kindergarten teacher told me, always put your software in a separate physical location. Put your files that change dynamically all the time, like your logs, your error logs, put them in a separate location. Get your physical files, put them in another location. Are any of you into Star Trek? Any Star Trek guys? 1, 2, The number one thing you learn in Star Trek, and this is important for being a DBA, you better be very careful, but you should almost never ever mix matter and antimatter. So from a DBA perspective, your matter is your data, your antimatter is all the log files that you need to do recovery. So from a MySQL perspective, we want to put, for those of you that believe at least to some level of OFA inside of Oracle, you want to put files of different types, utilization, backup recovery, importance in different locations. You want to do the same thing from MySQL perspective. So I believe that you should not put your, if you're going to be a real production DBA and you're just not playing with MySQL, you don't want to put the software in the default locations for the operating system. The other thing is, if you install MySQL on Linux, you got to understand, a lot of the people that are now experts at MySQL, they didn't start out as hardcore production DBAs. They started out as developers, web developers, and they started installing MySQL, so they use the default method. So if you install MySQL on Linux, and I realize this is a Windows platform, and just a little FYI, is it's going to put files under user local. It's going to put things under bin. It's going to spread things all over the place. And if you've been an Oracle production DBA on a Linux or a Unix environment, I'd rather go get my gun scraped with a wood drill than put important database files all over the place. So I'm going to go out and define where I'm going to put my software. And as a DBA, I'm going to define default locations like OPT, MySQL. Any Oracle DBA is going to understand that path. And then the release of that software, I'm going to name that directory 5.1.50, 5.5.1, and so on. I'm going to separate my data in a different directory. Now, when you define the data directory for MySQL, it's very important because that's where it's going to put all the database directories and the database files, which are your tables. Now, whenever we say database in Oracle, we think of all the physical files that are associated with the server. That includes everything. When you say database with MySQL, you're talking about a schema. Now, when you go out and you work in Oracle, you know how you have your system and your sysaux table spaces, that you have all of your system tables? In MySQL, we have a database schema. And in MySQL, the term database and schema are interchangeable. There is a default database that's out there called MySQL that's the same thing as system. That's what contains all your system tables. So whenever you define the data directory, and you've seen that in the configuration files a few slides back, you're going to go out and during the installation, it's going to create a subdirectory below data called MySQL. Whether you're doing it on Windows, Linux, Solaris, whatever. And that is where all your system tables are. Now, what does any DBA do? They go want to take a look at those system tables. Now, first of all, don't panic when you see it. Because first of all, there's a very small set of system tables that make up the MySQL database server. So the first thing most Oracle DBAs see when they look at that, they go, oh, my install must not have gone right, because there would have to be more files for database server than that. MySQL, it was designed to be three things. To be lightweight, to be incredibly fast and be very easy to install and set up. Now, if you want to go out and create additional database schemas, you can go out and create a database schema called World. You can go out and create a database schema called Fin. And it will also, when you say create database and you give it a name, the database server will go out and create a subdirectory below data with that same name. Then, to go into that database, you type use, and then you specify the name of the database. So if I want to go into the World database schema, I would say use database semicolon. Now, I can go in there and create tables, create indexes, create stored procedures. Now, if I go out and create a table, and I type use the name of the database first, then any table I create the physical files for it, depending upon the storage engine, it's going to put them in that subdirectory. So you can immediately go out to Windows, go to Windows Explorer, and see below that World database that you've got physical files. Now, the storage engine you work with, they each have their own file names and where they put the files. So storage can vary based upon the storage engine that you're working with. If I go into World and I create a city table and I make it a MyISAM table, a MyISAM table is going to have 3 physical files. It's going to have a .frm file, which is basically the table descriptor, all the metadata information about the table. You're also going to have an MYD file that's going to contain all the data for the table, and you're going to have an MYI file that's going to contain all the indexes for that table. So if you have primary and secondary indexes, they're all going to be in there. If you go out and create an NODB table, any table that you create, no matter what the storage engine is, it will always build a .frm file and it will store it inside of that database schema's subdirectory. And what MySQL uses for NODB is it uses a default file called objdata where it will put all the tables and the indexes of type NODB in that one default location. Now these are all just defaults. You have flexibility in where you can put things, and that's covered in, if we had more than an hour I could get in more detail. But the main thing I want to stand at here is that each table for different storage engines are going to have different characteristics, and the physical locations of that storage and the names of the files are going to be different depending upon the storage engine that you're working with. Oracle DBAs. This is going to look very similar to you. So I go out and I get my software, I get my database created, my database server created, and I'm now ready to bring it up. If you're working in Windows, if you go through the MSI installer, it's going to create a Windows service for you. So if you don't have it automatically come up during boot, you can just say net start, and you work with your service, and it'll bring up the MySQL database server. If I want to shut it down, I can say net stop. One thing to be aware of with MySQL is, you know how in Oracle you can bring up an Oracle instance in no mount mode, then mount mode, then you can bring it all the way open? MySQL doesn't have that. You can just bring the server up, you can just shut it down. You can't bring it up in different modes and shut it down in different modes. It's all the way up or it's all the way down. Now, when you bring the MySQL database server, it's going to start an instance. An instance is a section of shared memory that contains all the main buffers and caches. So just like you understand the database buffer cache, the shared pool area, and so on, MySQL does exactly the same thing, but obviously its shared memory has its own caches and buffers inside of it. And then along with that, you don't have a listener. The MySQL database server, the background process, MySQL D, will be listening on the port for you. So there's no separate listener that you're concerned about. Now, when you go to establish a connection to an Oracle database server, Oracle will start up a server process to handle all your processing of your SQL commands. MySQL does the same thing, but it starts up a thread. So Oracle is server process based for each connection. MySQL is thread based. So if I have 2 people connected to the system, I'll see 2 threads. And in Unix, you can do a PS command and have it list your threads, and you can take a look at it. You're going to have administration logs. The one log that you're going to have is the alert log, or the equivalent of the alert log, which is the error log in MySQL. You can also do some additional things. You can start up a general log that will capture all SQL commands and store them inside an ASCII text file. Now that's obviously something that you would not want to have up all the time, you typically start that up and you say, you know what, I don't understand what's going on with my server. I just want to start capturing all the SQL commands that are running against it for a certain time to kind of figure out what the problem is. And once you fix that problem, you make sure you turn off that general log. You can also start up a slow query log. You can specify a long query time interval, and for every SQL command that exceeds that time threshold, it will automatically get stored in the slow query log. You can go out and monitor that and be proactive and say, you know what, why are the SQL commands coming here? What do we need to do to go out and fix them? We also have binary logs. Now, this is one of the hardest things to get Oracle DBAs to get to because you've worked with your redo logs and archive logs for so long. But the way the binary logs work in MySQL, they only store DBL commands and DCL commands to change the database server. So the way it would work is if I shut my MySQL server database down and I did a full backup, I then brought the server back up and people started doing inserts, updates, deletes, create tables, drop user, any command that changes the database server, those commands will be stored inside of your binary logs. And they don't rotate like redo log files. You'll have your first file, your second file, your third file, your fourth file, and so on. So let's say that at that point in time, somebody wiped out the file system where I had my data. Now, if my logs are in a separate location, that's a pretty good thing, right? That's why I say you don't mix matter and antimatter. So then what I could do is, I could actually go out and get the backup of MySQL, put it on a new file system, get the instance up and running, and then I can execute all the commands that are stored in my binary logs to return my database server to a point in time. My ISAM, whenever you do an insert, an update, a delete, it writes it directly into the physical disk, and that change is permanent. As I said, there's no rollback command. It's a permanent change that you made in the physical disk. When you are working with InnoDB, it's our transactional storage engine. So whenever you do an insert, update, delete, just like in Oracle, you're going to have a before image, and you're going to have an after image. And if you do a rollback, it returns the state back to the information that you had in your before image blocks. What MySQL does with InnoDB is it has its own separate transaction logs that can do the equivalent of instance recovery of if people are doing all kinds of inserts, updates, and deletes, and the database server crashes. Well, at that point in time, MySQL is writing into a MyISAM file. You can corrupt that file. So you've taken all the protection off. MyISAM is very, very fast for reads. But as I said, the protection's off. It's designed to just do reads really, really well. If at that same time, InnoDB, you're using that and the server crashes, when that MySQL instance comes back up, it can take a look at the InnoDB transaction logs and perform recovery on them, similar to how Oracle will do recovery on your tables. So, depending upon the storage engine you're working with, you also have different types of memory that they work with. MyISAM, as I said, is designed to be very, very fast for reads. So what it does is you have something called the key buffer cache. And that is going to store current versions of indexes in memory because it wants the access for your data to be very, very fast. So whenever you go out and do an insert into a new record, the indexing information is going to go into memory. But the changes to the data, as I said, are made to the physical disk right away. When you're working with InnoDB, you have something called the InnoDB buffer cache, or buffer pool. That's the equivalent of the Oracle database buffer cache. So whenever you go out and do an insert, update, and delete, it's going to go out and first of all, your thread is going to go out and take a look and see, is the data I'm looking for currently in memory? If it is, it just gets it, just the way Oracle does with the database buffer cache. If it's not there, it'll go down to disk, get it, and load it into memory. And it will build an LRU algorithm, similar to how Oracle does. So the current data for InnoDB is going to be in memory. It's not going to be on the disk. With MyISAM, the current version of the data is on the disk. So you understand how the database buffer cache works in Oracle. So as people are doing inserts, updates, deletes, and querying data, with NODB, all the current data ends up going into that NODB buffer pool, and then people are getting their current information from that. Now, as you understand, over a period of time, that NODB buffer pool is going to fill up. Once it fills up, it has algorithms similar to Oracle in terms of how can I get the oldest data that hasn't been used in the longest time, so I'll have the capability of loading new information in. You understand that when you make a change and you do a commit, those change vectors get written to the NODB log buffer, similar to how Oracle does it. I'm here we're keeping it at a high level, but the goal is the same thing. They have your change vectors go to the NODB log buffer, and then those changes get written to the NODB transaction logs. So just like in Oracle, you have your current data in memory, but you have persistence from the transaction logs. So that way if your server crashes, whatever's in memory gets wiped out. But NODB, when it brings up those NODB tables, it can look at the transaction logs and restore that data to the last valid transaction. And just like with Oracle, if you're in the middle of a transaction and the database server crashes and you work with NODB, it's just like in Oracle, either the whole transaction successfully commits or the whole thing gets rolled back. Well, what happens if I have my transaction logs, they're recording all kinds of new information, and what happens if over a period of time you see how your data buffer and your transaction logs, they get out of sync, correct? And if they get too far out of sync, what's bad about that? What's bad about that in the Oracle world? You got long recovery time. Because when the database server goes to come back up, it says, hey, I'm not in sync. I got to apply all those changes, and I got to get the server back in sync. You all understand that we periodically want to get balance again. And we do that with checkpoints with MySQL. So what's going to happen, the transaction logs and the data buffer are going to get out of sync. A checkpoint's going to occur, and it's going to sync it back up. Then they get out of sync. So obviously, if the database server crashes and it has to perform recovery of that data, where's it going to go? It's going to go take a look at the last time a checkpoint was performed, because it knows it has to look at all the transactions that were in progress after that point. The difference is MySQL, they want everybody to use it. If you look at the owner of Facebook, he was asked, out of all the database servers that you could have picked, what made you pick MySQL to run Facebook? And he said, because at that point in time I was in college, I didn't have any money, MySQL was free and it was easy to use. So MySQL doesn't want you to have all the burdens, to have all the complexity of an Oracle DBA, or any other database vendor. So what MySQL does is, they do most of the checkpointing and the algorithms for optimizing it for you. So you don't have 5 billion parameters that you have to try to learn to make sure that that checkpointing is done from an optimal perspective. MySQL does a lot of things to keep you between the yellow lines. Another way it does that is there's a number of tools that you can use that will make your job a lot easier. A really, really nice tool is the MySQL Workbench. That's the database design tool where you can go out and build your data models. It can do forward and reverse engineering. Within that tool, you also have GUI interfaces. GUI interfaces are your screen scrapers. I want to be able to click on a table, click on the columns, and drag it over, and it builds a SQL code for me. And it also has some administrative interfaces that you can go out and say, click, 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 create a user for me, click, 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 go out and create a table for me, to help you with basic administration things. You also have something called the MySQL Enterprise Monitor. This is designed for monitoring and managing a MySQL database server environment. But I want you to understand, it's nothing like OEM. It's a very, very light version in terms of doing monitoring and performance and working with tools that can help you, like advisors. It's a very, very nice tool to use. It's just not heavyweight like OEM. You also have a number of utilities. For example, you've got the MySQL dump to do your logical backups. You've got the MySQL admin, sorry, there's a typo there. It should be my instead of pi. MySQL admin. And you can do this, things like this, you can use like a Unix environment to shut down your database server. You know how in Oracle you can do a TNS ping? With the MySQL admin tool, you can do the equivalent of a ping command. What that will do is that will go out across the network, hit that host system, and go to the port. And if the MySQL database server on the other side can respond to that ping, it'll say, I'm alive. And if it does that, at least you know the database server is up and running, and it's at least responding to requests coming through that port. So there's a number of nice little administration features that come with this utility. And then, it's kind of funny. You go out and spend $10 million on somebody's database server license, and then somebody says, well, I want Toad at $1,000 a seat, and people don't mind paying for it because they just spent $10 million to get the database server. If you get MySQL and you get the database server for free, the companies don't want to spend any money on anything else. So the nice thing about that is there's a lot of tools out there that work really, really well in terms of client GUI interfaces and so on that you can work with to help you interface with MySQL as well. And some of the more popular ones are NaviCat, SQL Yog. A lot of people that go out and get a host system because they want to build their own website, well, that host system is not going to let you get access to the Unix operating system prompt. So there's a PHP tool called PHPMyAdmin that you can go out and set up a web server, and you can use that as a GUI interface to go out and create new tables, to go out and add a primary key, and do basic administration. And then you can actually even use Oracle SQL Developer. So you can actually go out and connect CR tables, write basic SQL commands, but at this point in time, it really hasn't been optimized for all of the MySQL uniqueness, but at least you can connect and look at tables and run some basic queries. So I wouldn't use it as my main tool, but if you're primarily an Oracle DBA and you just periodically need to go out and look into MySQL databases, if you're comfortable with the tool, you can stay with that. And Toad also has a free version that you can use to connect to MySQL. As you know, a lot of Oracle DBAs, they use Toad, so you can use that as a single interface for both environments. Looking at connecting to MySQL, you've got the MySQL client tool. It's like connecting through SQL+. You'll specify the host option in terms of what's the host system where my database server is running. Up here, I use the IP address. You then have to specify the port. The port is 3306. And you know how you have the sys user in Oracle? That's like, Yoda. In MySQL, the equivalent is called root. That has nothing to do with the OS user. It's a user inside the database. That's our super user. So you can connect with root. You do -P for a password. It'll prompt you with a password, and then you can connect. The MySQL client tool has two different options. You can use a dash and a single letter option, like -H for host, or you can use two dashes and use the verbose option. You can say --host. Now, if you use the double dash options, then you have to have an equal sign. And whatever you prefer, potato, potato, it doesn't make a difference. Just giving you another feel for another set of utilities, you've got the MySQL dump. So you can use that to go out and do simple backups, but I want you to understand they're logical backups. So it's building all the DDL code and all the DML code where you can actually rebuild that from scratch. There's no intelligence to it. It just goes out and dumps all the commands that you would need to rerun it. So just think if you were doing a backup of a table that had 50 million records. You're building an ASCII text file that's going to have all the SQL code to rebuild that table and repopulate it with data. So obviously the MySQL dump utility is a great tool to do simple backups, but once your database servers start getting to like 5 gig or 10 gig, you're not going to be happy with the performance and the way that works. You can also do a full backup with the --all databases. Now, I didn't have enough room to keep it from wrapping around, but obviously if I'm connecting to the database server and reading information, there should be like a -u root -p to specify the connection information to get in there. So both of those MySQL dump options should have -u root -p. Now, all I've done is I've built a backup script, right? That has my create table command, all my inserts. So then if I want to run that backup, basically I can do a redirection arrow with the MySQL client, specify the user ID and password, and then following that is the name of the database. Here it's called MySQL database. So what it will do is it will connect to MySQL, it'll set the environment to that database, and then it will go out and run all the commands that are in your backup file. Now, are their tables still there? Is their data still there? This isn't making any decisions. It's just saying whatever commands are in that file, I'm going to rerun. So be careful with that. Another nice thing with MySQL is with any of the client utilities, you can say --help, and it will give you all the information in terms of parameters, options, and so on with the tool. The other thing is, you understand that Google uses MySQL everywhere. So when you start learning Oracle, I think one of the things that's the most difficult is you have to figure out what manual do I go to find how to figure this out. We all learned about the concepts manual, the SQL reference manual, the Oracle reference manual. In MySQL, I've never spent any time messing with that. You just go to Google and you type MySQL and you specify some command or what you're trying to do, and usually one of the first 3 links is going to be that, what you're trying to get to, and it'll point you to the right reference manual. So it works really, really well to get you to the right place right away. Okay, let's talk a little bit about Oracle and MySQL, and if you're coming from this environment, what do you need to know? First of all, as you all understand, Oracle is incredibly feature-rich. MySQL is designed to be very lightweight and fast, and that's what makes MySQL awesome. When I first joined MySQL, after my first month, I thought, oh my God, I made a horrible mistake. MySQL doesn't do this, MySQL doesn't that. There's another thing that MySQL doesn't do that Oracle does. And then, you know what turned me around? Were customers. A customer told me one time, Oracle's an aircraft carrier. And if you need an aircraft carrier, it's a phenomenal one. But all we need is a fast speedboat. We need applications that can go out to a database server, get access to them, and return that information very, very fast. So the more that MySQL is designed to be fast and to be lightweight, the more customers really liked it. And think about it. All the web developers today that are building .NET, Java, PHP, all the web tools that are out there, how many of them are writing database vendor-specific code in their apps? You all know that they're not, correct? So as long as a web developer can write a simple command and hit a database server and have it come back incredibly fast, because it's not trying to do 5 billion things for everybody, it's designed to just return that information really fast. That's why MySQL is really popular. I'll tell you, MySQL is flat out kicking everybody's rear end in terms of web databases. Now, as everybody's going to the cloud, what's becoming the most popular database that deploy in the cloud? MySQL, lightweight, fast. So you need to understand, take off your Oracle glasses and put on the MySQL glasses saying this database server is designed to be fast. It won't do 5 billion things, but everything it does is going to do very, very fast. You have an Oracle instance and you have a MySQL instance, very, very similar as I showed you. Oracle has system tables in the system and the sysaux table spaces. In MySQL, you have a MySQL database schema that has your main server system tables. And then for all of your database schema objects, like information on tables, procedures, events, which are basically like cron jobs, it's a schedule that you can run in the database server. All of your database schema metadata is going to be in a database schema called information_schema. In both database servers, you can have stored procedures, you can have functions and procedures, but in MySQL, it does not support packages. So as you know, with Oracle, you've got all kinds of additional feature functionality that comes with all the PL SQL packages. MySQL has no concept of packages. How many of you have been a DBA since back in the version 7 days? So for those of you that have done that, that's what a MySQL DBA is. Because you all understand that in Oracle 11g, there's this massive infrastructure, there's OEM that has all these things helping be a DBA. But back in the version 7 days, we didn't have all that stuff. You had to write Unix scripts, you had to write those scripts to get that database server to work the way you wanted to. That's the way MySQL works. You all remember back in the Oracle version 6 and version 7 days, you didn't have all these fancy wait events. You used hit ratios, etc. MySQL is the same way. It doesn't have tons of wait events. You're going back to more of the Oracle 7 style of how you performance and monitor a MySQL database server. The client tool for MySQL is called MySQL. Here you've got RMAN and Data Pump to do backups and exports. What you're going to love about exporting and importing in MySQL is it's really simple. What you're not going to like about it is it's really simple. You'll use an export. You basically run a SQL command that does a dump to a file. That's the MySQL export. There's the capability of running an import command that just loads the data back in. It doesn't have 5 billion options, but it's really good at just dumping the data and loading it back in. We talked to you about the configuration files. MySQL has no concept. You know what? I got those things reversed. Oracle has Oracle Net Services, you all understand. With MySQL, it's all over TCP/IP. You don't need any additional database software to connect. As long as I can go across a network and I can hit a port on a server, you can connect to a MySQL database. And then it uses sockets. So if you like SSH into the host system and you go to connect to MySQL locally, by default, it's going to see that you're coming in from the local environment and it's going to connect you over sockets. Now, if you're working with Windows, you can also set up pipes or shared memory connections. And for the most part, you probably don't want to do that. You'll just stay with TCP/IP because both those methods are really slow. But the nice thing about being able to work with sockets on Unix and Linux and pipes and shared memory on Windows is the fact that what I might want to do is I might want to shut the database server down and I want to bring it back up, but I want to bring it up in maintenance mode. I want to look at it, but I don't want people trying to use it while I have it up. So what I can do is when you bring up MySQL, there's a networking option, a skip networking option, so it'll come up, but it won't be listening on the port for incoming requests, so people from the outside cannot get in. But then I can still connect over a socket and do things locally. And I can do the same thing with Windows, but I could go out and turn the skip networking, turn that option off so I'm not doing any networking, but I can come up with a shared memory connection so I can still connect locally to go out and say, I just want to make sure that the upgrade went really well. Some other things that kind of stand out, if you look at in Oracle, you've got global parameters and you have session parameters. MySQL has exactly the same thing. You've got some parameters that can only be changed globally, some can only be changed at the session level, some can be changed at both. In Oracle, if you look at the top, you would say like alter system, get a parameter, and you can say scope equals SP file, etc. If you look towards the bottom with MySQL, instead of saying alter system set, you just say set, the name of the parameter, and you give it a new value. One of the things that you also have when you first become an Oracle DBA is you have to understand the data dictionary. You don't think about it now because you've done it for years, but I bet you the first time you became an Oracle DBA and you tried to learn the data dictionary is a little overwhelming. Well, people want MySQL, they want to be able to use it very easily. You know what, I'm starting up my own t-shirt company, and I realized if I could do it all over again, I wouldn't have gone to college. I would have started up a t-shirt company because there's a lot of $10, $50, $80 million t-shirt companies out there right now. I guess that's a different story. But anyway, I want to start up my own t-shirt company. I don't know a lot about databases, but I'm going to use MySQL for my website. Well, what you can do is you can log into MySQL and you can type show databases, and it will show you all your database schemas. You type use database and you type show tables, it'll list all your tables. So MySQL has a lot of options in the show command that can pull that metadata out for you very easily, and you're not having to understand all the data dictionary tables and columns and what they do. You want to take a look at triggers, you can type show triggers. In Oracle, you would type select name value from the $sign parameter to take a look at your server parameters. In MySQL, you can just say show variables. So once again, very, very simple to get up to speed. Both Oracle and MySQL, they both use the cost-based optimizer. Now, the nice thing about this is MySQL will keep you between the yellow lines, because even if you don't generate statistics, MySQL will periodically update those statistics and not let you get too far out of sync. Now, you should still be generating statistics in MySQL, but if you come into an Oracle database server and you generate 0 statistics, you're in a lot of trouble. With MySQL, it will always have some statistics for you. Query optimization. In Oracle, you've got a lot of different join optimization methods. In MySQL, you only have one, nested loop joins. Everything, if you're doing joins, they're nested loop joins. All the concepts that you learned in Oracle for the last whatever many years, most of them are going to apply to MySQL and optimizing joins. They're both going to support regular tables and indexes. So everything that you learn on what are the common sense things you do to work with tables and indexes, defragging them, rebuilding indexes. Should I do a full table scan? Should I do an index scan? The same concepts apply in MySQL. They both support temporary tables. There's just a slightly different implementation of them. They both support partitioning. The nice thing is, partitioning in MySQL is free, which is a very cool feature. And then here, I just listed at the very bottom, there's a number of different storage engines that you can get. Some come with MySQL, so at the MySQL prompt, you can type show engines, and it will give you a listing of all the available storage engines. MySQL also supports a plugin architecture, so you can add additional storage engines. So you might be in a scenario where, you know what, we're doing a lot of really heavyweight video streaming, or we're doing a lot of heavy I/O operations for like a data warehouse. And even though the MySQL storage engines are great, they really weren't designed for that type of heavy utilization. So you can actually go out to third-party companies and purchase storage engines from them that are designed for very special types of workloads. To me, one of the greatest names, there's 3 great names in the IT industry. Even though it came from the Antichrist, whoever came up with the name of SQL Server, that is a great name for database servers. The second great name is RAM. I met somebody, his name is Ramachandra. He goes, but you can call me Ram for short. And I go, oh my God, you're Ram? I go, everywhere I go, all you hear is, if we had more RAM, we could fix this problem. To get this done, we need RAM. I go, you're Ram. I made like a big deal. Totally embarrassing, but I had a lot of fun with it. To me, the third great name is Black Hole. For someone to build a storage engine and call it Black Hole, that's just brilliant. I don't know if that came after a lot of vodka shots some night, or someone really meant that intention, but that's also a great name. When you do an install, you have to decide, am I pretty much a Windows administrator, and I want my MySQL database software to work and kind of be laid out like all my other Windows software? Then do the standard install. If you're primarily a Linux administrator and you know a lot about Linux or Solaris, but you don't know a lot about MySQL, then I recommend you use the default install. But if you're a production DBA and you believe in conforming to certain levels of the basic fundamentals of OFA in terms of how you lay out a production server, then you want to separate all these important things. Now, with all of you being Oracle DBAs, I don't have to tell you the value of you going out and having your software separate from your binary logs, from your main administration files, from your backups, your transactional data, your data directory. You should use those same practices with MySQL. Now what I did is I created something called MOCA, because I was teaching a MySQL class and I was explaining that, hey, it was a really big company and they were going to be implementing MySQL all over the place, so I was teaching them a lot of best practices. And they go, where can I go get information on that? And I go, well, there really isn't information out there. And they go, would you write it for us? So I said, okay. So I created something called, oops, I must have hit the wrong button. Sorry about that. I created something called MOCA. I wanted to call it DOCA for George's Optimal Configuration Architecture, but I thought, I probably shouldn't do that. So I went the whole Java coffee thing, and I called it MOCA for the MySQL Optimal Configuration Architecture. And basically what it is it really just takes a look at best practices on how you should lay out a database server. And it's very similar to OFA. Here, starting and stopping a MySQL instance. On Windows, we talked about installing it with a service and using net start, net stop, bring it up and shut it down. If you're working not with services, or you're working on a Linux and a Solaris system, you can type MySQL-D, and if you're working on a Linux system, you can say ampersand, and you can basically just run the executable. It will go look in the default directory path, find a configuration file, know what port to listen on, and it will come up. So you can bring it up manually. You can also use the MySQL admin utility to shut down the database server. Now, I never want to question the infinite wisdom of the MySQL gods and goddesses, but the MySQL admin tool has an option for shutdown. It doesn't have an option for startup. Yeah. Don't ask me why. If you're working on Unix and Linux, there's a shell script called MySQL-D_save that will bring up the MySQL instance, and it will start up a process to monitor it. And if it sees that MySQL instance crashed, it will try to restart it for you. If you want the MySQL instance to boot on a Linux or a Solaris system, when the hardware system reboots in your init.d directory, you You can also work with a shell script called MySQL Server that can be used to start up your server and to shut it down. And then if you're a Perl head, you can download from the internet something called MySQL multi, which is basically a Perl script that can help you in terms of starting up and shutting down remote database servers. Something that's very important, I'm running out of time here, but you got something called the SQL mode. Make sure you set this properly. This controls the level of data integrity that the database server will enforce. People think that, oh, MySQL doesn't support data integrity. That's not true, it does. You just got to turn it on. And on Linux and Solaris systems, the default is it's wide open. You can put in bad data, total garbage, and your insert will not fail. It may truncate data, it may say that the default values, but the insert will work. If you want it to have tight data integrity like Oracle, you have to turn it on with this parameter. This parameter also determines how SQL code is interpreted. So you understand the two vertical pipes, you can do string concatenation. You can also use two vertical pipes for a logical OR that will return a 0 or a 1. Well, when you run the SQL command, which are you going to get back? It's how this parameter is set. So make sure that you spend some good time going out and setting this to the appropriate value for your database server. Now you understand the problems if you don't know about this and 6 months later you go to set it up. That means that you have one set of data that was put in with one level of data integrity, and all the new data that goes in is going to be under a different level of data integrity. If you want to run SQL scripts, it's the source command. Source the name of the script, and it will run whatever code's in the start of it, similar to the start command in SQL+. You've got a T file. You're familiar with this concept. Now every command that I type and the output will display not only my screen, but it will store it in the physical file. Just like you can do it in SQL+, but we use the T command. Along with the information schema and the MySQL database, I talked about the show commands. There's a describe command where you can go out and say describe table. And there's also a client tool that you can run from the operating system prompt called MySQL show that will do some base show commands as well if you want to run it from like a shell script, etc. Take a look at isolation levels. This is a big deal. The default isolation level in Oracle is read committed. In MySQL, it's repeatable read. Which means when you run a SQL command, you see one set of data, but now you're going to be looking at the data from the point in time that you started your transaction. So if somebody else goes out and does an insert and commit in another session, and you now query the data after they did a commit with repeatable read, you will see the original version of the data. You won't see the changes until you change your transaction time. For example, typing commit and rollback. Now that seems really weird for Oracle DBAs, but you got to understand, MySQL was created to be a web reporting database, so it made reading the priority. So you better make sure with that parameter for database isolation, if you want your database server to work in read committed mode, that you set that parameter. Things that you want to make sure you do. Determine, you understand as a DBA, set proper guidelines and standards for how you're going to install it. I've got a website you can go to, do a search on MOCA, and basically it will come back with why you want to use it, what are the standard guidelines, and basically I take you through a MOCA installation on Linux, Solaris, and Mac OS. Make sure you set the SQL mode. In MySQL, if you're working with a case-sensitive operating system, your database name and your table names are case-sensitive. So there's a parameter you can set, lowercase table names, and that will actually make sure that all your data gets stored in the metadata in lowercase. Make sure you work with the right storage engines. MySQL doesn't support roles. So basically, you're going to have to build the equivalent of stored procedures and scripts to go out and implement how you want to set up security, because you understand attaching individual privilege to individual users and the permutations is like impossible. If you go to the MySQL website, there are standard scripts that people have built to set up the equivalent using scripts to create a simulated role-based security model. And if you think, if you're new to MySQL, what's the probability that you're going to do something in your first 6 months that somebody hasn't already written? MySQL is the most popular database in the world in terms of utilization. There's tons of scripts out there. Backup and recovery. We don't go into this in this presentation, but very popular forms of replication is very popular to do backup recovery in MySQL, and also using like operating system snapshots is also very popular with MySQL. Just remember that the MySQL dump logical backup is only really good for small database environments. And then you need to determine what are the tools that you're going to use to monitor your database server. 5.5, read about it. It's a complete game changer. MySQL, as I told you, is kicking everybody's rear end on the web because it works so well. But the thing is, in the 5.1 release, it scales horizontally with replication. So you have a rewrite database server, you replicate to a bunch of read servers, and then you can get tremendous scalability. In 5.5, MySQL scales vertically very, very high. It's scaling with like 8 and 16 cores. So they've rewritten a lot of the code. It's designed to be a very fast vertical database. So it's going to flat out, I would be shocked if it just didn't kick SQL servers around all over the place in terms of small and medium-sized database servers. The value proposition on Windows. One, you work with the most popular database server in the world in terms of utilization, the number of instances. So all of a sudden, if your company's going to go from Windows to Linux, MySQL will run on Linux. It'll run on Solaris. It'll run on, Mac OS. It'll run on all the popular OSs that are out there. It's, as I said, the most popular database to deploy in the cloud, so you're going to see more and more MySQL being used. Very fast, very lightweight. If you want, it's not tied into the registry. You're leveraging open source, and it's got some great tools in Windows. Everybody, thank you very much, and have a great conference. And the last thing to talk to anybody this week, MySQL. Take care.